Hello again, everyone. So I'm here again for another lesson for engineering economy. So now we have the second type of annuity, which is due annuity. Okay, so for due annuity, I'm just gonna recall a bit. So for ordinary annuity, the payments are made every end of the month. Okay, so for due annuity, that's the second one, the second type of annuity, we have payments are now made every beginning of the month. So that is the only difference. Since they only ordinary and due annuity only has a little difference, their formula will also have only a little bit of difference. Okay, so going into the formulas, so let's just recall. Okay, so for the formula of ordinary annuity, we have the future amount times the annuity. Okay, so this is 1 plus I raised to yn minus 1 all over I. So this is the formula for ordinary annuity. So to make it the formula for due annuity, all you have to do is just add this one here. 1 plus I. And then that will be your formula for due annuity. That's it. So that is how easy it is. So I'll just write this one. So you can also write this one like this. So that's 1 plus, again, I is just equal to j over n. You can replace I with j over n raised to yn minus 1 all over j over n. And of course, don't forget the additional factor of 1 plus I, which is j over n again. Okay, so going to the formula of present worth, this is also just the same. All you have to do is just add that factor. So for the present, you have 1 minus 1 plus I raised to negative yn all over I. And again, adding that factor, we have 1 plus I. So you can also write this as in terms of nominal rate of interest. You can have here 1 minus 1 plus j over n raised to negative y over n. So this is 1 plus j over n. So there you go. So this topic doesn't need a lot of explanation. It's just the same with ordinary annuity. The only difference is the payments are made every beginning of the month. Okay. So these are the formulas that we will use for the rest of this video. So with that, I think we can go for our first problem. Okay, so going for our first problem, so we have Engineer Chu bought a car. He is to pay this car 15,000 per month with an interest of 9% compounded monthly. So calculate the accumulated amount after 5 years if the payments are made in the beginning of the month. So as you can see, we have here payments are made in the beginning of the month. So we can now consider this as a due annuity since payments are made every beginning of the month. So we have, let's just put all the givens first. Okay, so given we have 15,000. He is to pay 15,000 per month. So that is your annuity because that is the amount being made every month. So this is 15,000 and interest of compounded monthly. So we have compounded, the word compounded. Therefore, that's a nominal rate of interest. That's 9%. And you should be in decimal form again. And calculate the accumulated amount. He is to pay this car 15,000 per month. Where is the year? or yun, calculate the accumulated amount after 5 years. So that's y must be equal to 5 years. And then we are now required to find accumulated amount. From the word accumulated, we are required to find the future worth. Okay. Okay. So let's try out the solution. So the solution now for this one is just straightforward. All we have to do is just direct substitution. So writing down the formula, we have F equal to the annuity times 1 plus j over n, since we are given with nominal rate of interest, raised to yn minus 1 all over j over n. So don't forget the additional factor of 1 plus j over n. Okay, so substituting the values you will have here, a now is 15,000. Okay, it's 15,000. And then 1 plus j, your j is 0.09. N is monthly. So we forgot to write here that n is equal to 12. Okay, that's monthly. So this is 12 raised to yn. So that's 5 times 12, right? And minus 1. This must be all over j over n. So that's 0.09 all over 12. Don't forget the additional factor, since this is a due annuity. So this is 0.09 all over 12. Okay, so I already input this in my calcu in advance. So the answer for this one will be 1,139,847.269. Okay, so that will be your answer. That only means that if Engineer Chu will pay 15,000, this one, per month with the interest of 9% compounded monthly for the whole 5 years, and all the payments will be made at the beginning of the month, the total or the lump sum of all his payments will be this one. Okay, so I think we can go for our next problem. Okay, so for our next problem, we have Engineer Recto bought a laptop amounting to 200,000 if paid in cash. So he plans to pay this laptop for 4 years at the rate of 7.5% compounded quarterly. So if the payments are made in the beginning of the month, how much must he pay per quarter? So again, we have here every beginning. So we have here every beginning of the month. Okay, so this is a due annuity. So what if there's nothing's indicated about when it is paid? So it doesn't so problem doesn't indicate if the payments are made either beginning or end of the month. What would you do, and what type of annuity is that? So if again, so if that the mode of payment, okay, is not indicated, it doesn't indicate beginning or end, all you have to do is just consider it ordinary annuity. So consider that the payments are made every end of the month. Okay. Okay. So putting all the again the given. So Engineer Recto bought a laptop amounting to 200,000 if paid in cash. Okay. So that's the total amount of the laptop laptop if it is paid in cash or if it is paid today. So that will be your present worth. Next, he plans to pay this laptop for 4 years. So we have y equal to 4 years at the rate of 7.5. So we have the word again there compounded. So that's j equal to 7.5%. Or this is also equal to 0.075. And compounded quarterly. So n must be equal to 4. Okay, so we can have now the required. Now we are required to find what? How much must he pay per quarter? Okay, so we are asked to find now how much must he pay every payment or every quarter. So we are looking now for the annuity. Okay, so going for the solution. Um, So we can use now the formula for the present worth. So remember, this is a due annuity. So we have P equal to A times, oops, we have 1 minus 1 plus J over N raised to negative Y raised to J over N, all over J over N, 1 plus J over N. So this is what I do to memorize all the formulas. So even though I already know the formula, I will still write the formula over and over again so that eventually I'll be able to memorize all the formulas. So this is how I memorize all the formulas in engineering economy. Okay, so substituting all the values, we have P is equal to 200,000. So I highly recommend you do this, especially if this is your first time answering this type of problem. All you have to do is just write the formulas over and over again, even though you already know the formula. Eventually, it will come naturally to you. So 1 plus J is 0.075, so N equal to 4 raised to negative 4. Your years is 4 and your quarterly is also 4, all over 0.075 all over 4. Don't forget the additional factor, that is 0.075 all over 4. Okay, so all you have to do is just solve for A. So you can do either algebraically or you can just use your calculator, whatever. I already solved this beforehand. So we have an answer for this one, which is 14,316.1425. So this is the amount that Engineer Recto will pay if he will buy a laptop amounting to 200,000, which has a this one 7.5 for 4 years compounded quarterly, and if all the payments are made in the beginning of the month. So this is the amount that he will pay every quarter. So with that, let's go to our next problem. Okay, going for our next problem, we have Engineer Como decided to buy a townhouse amounting to 5 million if paid today. He is being told that he is to pay this at the rate of 6% compounded semi-annually. If he is to pay 200,000 every 6 months. So how long it will take for him to pay the townhouse fully if payments are made at the beginning of the month. Okay, so let's put again, as you can see, we have here every beginning of the month. So this is a due annuity. So you always have to take note of that. Okay, so let's put all the givens first. So given we have amounting to 5 million if paid today. Again, today. The keyword there is today. So that is your present word. So this is 5 million. Okay, 5 million. And then he's been told that he's to pay this at the rate of 6%. Compounded again. So that must be your J. That's 6%, or this 0.06. And then compounded semi-annually. So N must be equal to 2. So if he is to pay 200,000, okay, 200K every 6 months. Okay, so don't be confused with this one, okay? So if he is to pay 200,000 every 6 months. So if he is to pay every 6 months, therefore how many times does he pay every year? Okay, so we have 12 months, right? So he is only paying 2 times a year. So that's just also semi-annually. So you don't have to change anything. So N is equal to 2 as it is. Okay, and then he's paying every 6 months, so that will be your annuity. So the 200 thousand, 200K. So how long it will take for him to pay the townhouse fully if payments are made at the beginning of the month? Therefore, we are now required to find how long. Therefore, this is we are asked to find the number of years. Okay, so this must be years. Okay, so we can now I'm writing the formulas first. So formula will be, we can use the formula for present worth. So P is equal to a 1 minus 1 plus j over n raised to negative yn all over j over n, and then the additional factor of 1 plus j over n. Don't forget about that one. Alright, so we can now substitute all the formulas, all the values we have. So P, or the present word, is 5 million. I think I can just write here 5M, okay, 5 million. I hope that's okay. And this is 200k. A is 200k. I think I can write that down. 200k, and then 1 minus 1 plus your j will be 6%. That's 0.06. Okay, and then all over 2. That is raised to negative. We are looking for y, right? But we have the value of n, which is 2. So this will become 2y all over 0.06 all over 2 times now 1 plus 0.06 all over 2. Okay, so all you have to do here is just solve for y and we are done. So you will be able to get the answer. So let's try to do this algebraically. Okay, so doing this algebraically, so what will happen? So this 200 must go down here. Okay, also this one, right? So these two must be on the denominator of 5 million. So writing that we have 5 million must be all over with 200k, right? 200k times this one, that's 1 plus 0.06 all over 2. Okay, so this is 5m. So this is all equal to this one, 0.06. You can just use your calculator if you want, but I prefer it always to do it algebraically all over 2. Okay, so what's the next step? So we can have here 0.06 over 2, that's just 0.03, right? And then we can cross multiply this one to here. So that will become now 5 million times 0.06 over 2, that is just 0.03, right? So this is 0.03, okay, all over, that's 200,000 times 1 plus 0.06 all over 2, and this is equal to 1 minus, I think we can simplify this one, that's 1 plus 0.06 over 2. 0.06 over 2 is 0.03, so this now will become 1.03 only raised to negative 2. Why? Okay, so next we can transpose this and then transpose all of this. So I can just get the value of this one, I think, so that it will be, no, it's fine. Okay, so going here, we can have, so this will be transpose. So that will become now positive 0.03 and then raised to negative 2y all over, no, equal to 5 million times 0.03, and then 200,000 times, that's 1 plus, that's also 1.03, right? Simplifying it. Okay, so what is the next step? We can take the ln of both sides. Okay, so taking the ln of both sides, you will have, so you'll have here ln and then ln. So taking the ln of both sides and then putting a negative, this negative 2, where this exponent go, this exponent can go down here, right? So this is now negative 2y ln of 1.03 equal to ln of 200k times 1.03 and then 5 million times 0.03. Alright, then finally, all we have to do is just put down this negative 2 and then ln 0.0, ln of 1.03 to here. So that will become his denominator. If you do that, your answer will be this one. Y will be equal to 22.0328 years. Okay, so this is how long that Engineer Como. So if Engineer Como decided to buy a townhouse, which is amounting to 5 million today, and then if he is to pay it at 6% compounded semi-annually, and then he's paying 200k every 6 months, and then all payments are made every beginning of the month, the total amount, no, it will take him 22 years to fully pay the townhouse that he bought. Okay. So I think I was okay, this is all again for this video, and again I really hope that I was able to help you with your lesson, especially these online classes. So if you have any question about this lesson, don't hesitate to leave a comment down below. And thank you for all of you for watching, and don't forget to subscribe, okay, and hit that bell notification icon so that you will be notified as soon as I upload a new one. So again, thank you all guys for watching, and I hope you are all having great days and keep safe in your houses. And thank you, and I'll see you on the next one. Bye bye.